Tonight we continue the Lowell series on physics with Physics of the Future, featuring renowned physicist, author, and popularizer of science, Michio Kaku. Whether your interest in physics is that of a professional scientist, enthusiastic amateur, or complete novice, you are likely to have encountered Dr. Kaku. With multiple New York Times bestsellers, including his recent Physics of the Impossible, and we're proud to announce, as of a few hours ago, we just found out that Physics of the Future debuted at number 7 on the New York Times bestseller list this week, including Physics of the Impossible. Thank you, Michio Kaku. Physics of the Impossible and the latest Physics of the Future. His regular television appearances on ABC, BBC, the Science Channel, and CNN, plus more than 70 articles published in science journals. He has addressed the great questions of physics and increased scientific awareness across all background levels. Just to give you a little idea of the breadth of his communication abilities, he's known to many of us as the co-founder of string field theory, but he's also known to many of us for providing the background on the physics of the series Firefly on the Science Channel right now. So as you can see, he covers a wide range of interests. In the spirit of great futurists such as Jules Verne and Leonardo da Vinci, Dr. Kaku will take us on a speculative trip to the future, grounded in interviews with over 300 of today's top scientists, whose current research is setting the course for the future of medicine, computers, artificial intelligence, nanotechnology, energy production, and astronautics. And one last thing to add, I was just reminded that New York Magazine has voted Dr. Kaku one of the top 100 smartest people in New York. Let's see how he does for a Boston audience. Please join me in welcoming Dr. Michio Kaku.
Well, after such a great introduction, I can't wait to hear the speaker myself. First of all, I have a confession to make. Yes, it's true that New York Magazine voted me as one of the 100 smartest people in New York. But in all fairness, I have to admit that Madonna also made that same list. So how accurate and authoritative could that list be? Well, today I'm going to give you a guided tour of what we scientists believe the next 20, 50, 100 years are going to look like. I've had the honor of interviewing over 300 of the world's top scientists, 2 scientists a week. My radio show, Science Fantastic, broadcasts actually in Boston, and it goes to 140 radio stations across the United States. I've had a chance to share their dreams about the future. Now, I'm a physicist. We invented the transistor. We invented the laser. We helped to invent the first computer. We helped to create the internet. We wrote the World Wide Web. We also invented television. We invented radio. We invented microwaves. We invented radar. We invented MRI scans, PET scans, you name it. There was a physicist there. And now we are inventing the 21st century. So you're going to get a wild ride as we go into the future. Now, of course, it's difficult to predict the future. Let me quote from that great philosopher of the Western world, Yogi Berra. Yogi Berra once said, quote, "Prediction is awfully hard to do, especially if it's about the future." Well, I'm a physicist. We love to make predictions. In fact, we predict trillions of years from now. We can actually predict what the universe may look like trillions of years from now. So let me now quote from that other great philosopher of the Western world, Woody Allen. Woody Allen once said, quote, "Eternity is an awful long time, especially toward the end." So let me now talk about the future. When we physicists helped to invent the internet, one physicist made a prediction. He predicted that this brainchild of theirs would become a forum of high culture, high art, and high society. Well, today we know that 5% of the internet is pornography. But that's because teenage boys log on to the internet. Just wait until the grandmas and grandpas log on to the internet. Then 50% of the internet will be pornography. So let's now talk about the future. My last book, Physics of the Impossible, talked about the world of science fiction. Some of these inventions go perhaps thousands of years in the future, when we can harness the power of black holes, build starships, time machines, warp space and time into a pretzel. I work in string theory. That's what I do for a living. That's my day job. And string theory is the only theory that allows you to actually make statements, rational statements about time travel. But today, we're going to talk about predicting the next 100 years. Some people say, ha, you can't do that. Well, here's a counterexample. The year is 1863, the time of the American Civil War. When most of America was mired in this horrendous war, Jules Verne in Paris predicted the next 100 years. He predicted, first of all, the moon rocket. He got the size of the capsule correct within 10%. He got the velocity of the capsule right. He didn't get the propulsion system right, but the rocket's propulsion system wouldn't be invented for another 100 years, so you can't blame him. And then he got weightlessness right. He predicted it would take 3 days to go to the moon, which is true. He predicted it would go from Florida, which it did, and splash down in the ocean. All of that correct. Now you may say to yourself, well, that's a fluke. Well, no. He did it twice. In 1863, he writes a novel, Paris in the 20th Century. It was so outrageous that his editor said, no, we can't possibly publish it. No one's going to believe it. It's so incredible. It was placed in a safe for over 100 years. It was in a safe. Several years ago, his grandnephew discovered it in a safe, and he realized, oh my God, we never realized. He predicted Paris in 1960, and it became a bestseller in France. What did Jules Verne predict? First, glass skyscrapers. Impossible, they said. Automobiles using gasoline. Fax machines. Something resembling the internet. It goes on and on and on. This is Paris in 1960, predicted by Jules Verne. And the question is, how did he do it? The way he did it was, anytime a scientist or a learned person would pass through Paris, he would pester them. He would sit down with them. He would say, tell me about electricity. Tell me about the dreams of space travel. Tell me about this. He was like a sponge. He wanted to know the future. So I said to myself, hey, I have two passions in my life. One of them is to know the future. You see, when I was a kid, I had two heroes in my life. First was when I was 8 years old. I still remember my teacher came in the room and announced that a great scientist had just died. It was in all the newspapers. Everyone was talking about this man called Albert Einstein, who had just died that day. And they flashed a picture which changed my life, a picture of his desk. And on the desk was the unfinished manuscript of his greatest unfinished work. It was in all the newspapers, a picture of his desk. Everyone was talking about the fact that he couldn't finish his crowning achievement. And so I said to myself, what was so hard? I mean, was it a homework assignment? He couldn't ask his mother? I mean, what's the big deal? I mean, why couldn't he finish it? And I said to myself, well, maybe I'll try to finish it. Well, then I went to the library and I began to realize that it was the unified field theory, the theory of everything, an equation 1 inch long that would allow us to, quote, read the mind of God. An equation 1 inch long, like E equals mc squared, that would unravel the secret of the origin of the universe, the secret of the stars, the creation of the earth, the creation of people, maybe even love. That's what he tried to do before he died. And then I had a second experience when I was a kid. Every Saturday morning, they would have Flash Gordon on TV. Every Saturday morning, I learned about rocket ships, aliens in outer space, ray guns, and hey, I was hooked. However, after watching Flash Gordon for a while, I began to realize a few basic things. First of all, I didn't have blonde hair and muscles. That's a big deficit. And second, I began to realize that, well, Flash, he didn't create anything at all. He just got into fistfights with the aliens. It was the scientists who made it work. The scientists who built the starship. It was the scientists who built the city in the sky. It was the scientists who built the ray guns, you know? And then I learned something else. The science of Flash Gordon, well, some of the science was done wrong. And then I said to myself, well, if Jules Verne can predict the future, why can't we as physicists today? So let's now take a journey to the year 1900. The year is 1900. What kind of world did our grandparents and our great-grandparents live in? Well, first of all, you were lucky, on average, if you lived beyond the age of 40. Most people were dirt farmers in America in 1940. High tech, well, there was no television, there was no radio. High tech meant the telegraph. If you were lucky, if you were rich enough, you had access to the telegraph. So what was life like? Life was short, brutish. You know what they say? You're born, and then, you know, you die. Life's a bitch, right? Well, that's the way it was. Talk to your grandparents. Talk to your great-grandparents if they're still alive. What was it like in the year 1900? Now, if you today could somehow visit your grandparents of 1900, what would they think? Here are a bunch of dirt farmers that have never seen a radio, never seen a television because they haven't been invented yet. And here you are talking about rocket ships, atomic bombs, electrification of the world, automobiles that can race 140 miles an hour when the fastest you could go was maybe 15 miles an hour on a horse, if you were lucky to have a horse. Most people didn't even have horses. So they would view you as wizards and sorcerers. Now, hold on to your seats, because now we're going to go to the year 2100. If someone from 2100, your grandkids, if your grandkids were suddenly to walk into this door, how would you view them? What kinds of technologies would they have? You would say that they would have the power of a god of mythology, because that's where it's all headed. They would mentally control computers, and I'll show this. Everything in this lecture is based on an existing prototype. This is real. This is not Flash Gordon. We're talking about science today that we physicists are creating. The ability to move objects with the mind, like Zeus, to be able to rearrange matter in your own image, like the gods. And, hey, there are perks involved too. Perfect bodies, ageless bodies. We'll talk about that in a minute. And then chariots. Apollo had a chariot that would take him right into the sky. We will have flying cars, finally. Okay? Took us long enough to get that one. Okay? And then Pegasus, the flying horse. We will have zoos of extinct animals. We're going to bring back the mammoth. We now can visualize bringing back the Neanderthal. This is not science fiction. This is stuff that I've interviewed scientists for. We're talking about the stuff that our grandkids will experience. However, there's a downside. The power of the gods. Well, will we also have the wisdom of Solomon? You know, if you read Greek mythology, you begin to realize that the gods spent most of their time chasing each other, engaged in mischief, and even Loki, the god of mischief, brought down the gods. Twilight of the gods, Ragnarok. And so the question is, will we have the wisdom to handle this mythical godlike power? We used to fear the gods. Now we will become them. And the question is, are we wise enough to handle this power? So let's begin. Let's begin with today. Today, we have something called Moore's Law. This chart here is the most important chart of the later half of the 20th century. The fate of nations, the wealth of the world is dependent on this one chart. It is the most important chart in modern times. Moore's Law simply says computer power doubles every 18 months. At Christmas time, your computers are just, well, twice as powerful as they were the previous Christmas. You can see that in a log chart. It's a straight line. 50 years computer power has been doubling. Well, extend it to 2020, and you realize that chips will cost a penny. And when chips cost a penny, that's the cost of scrap paper. we will just throw them as scrap paper. Computers will be everywhere and nowhere. Because where is electricity today? Years ago, when you had an electric motor, you had to arrange your whole factory around one electric motor. That's how precious electricity was. Today, we assume that electricity is under our feet. It's in the walls. It's in the ceiling. We assume that electricity is everywhere and nowhere. Invisible, but everywhere. That's where computer power is going to go. Where will your PC go in the future? Your PC will disappear. Intelligence will be in the ceiling, walls, floor. You will simply talk to things, and your kids will wonder, how could you possibly live in a world where everything was stupid? You mean you can't talk to anything? Nothing responded? I mean, a table was just a table? I mean, give me a break, Dad, okay? Well, every decade, look at Moore's Law. In the 60s, we had gigantic mainframe computers. In the 70s, we had mini computers the size of this podium. That's what a computer looked like in the 70s. In the 80s, we had the PC. In the 90s, we had the internet. And in the 2000s, we have ubiquitous computing. Chips are slowly going into the environment. And I'm going to show you what's going to happen in the next 10, 20, 50, 100 years. Next will be advanced sensors. You will have more computer power in your bathroom than in a modern hospital. And after that, control of computers with the mind. So this is the internet. It is the magic mirror. And look at this. Where there's the internet, there's wealth. So you can ignore technology if you want, but you'll just be poor. Technology generates wealth. That's one of the main content of my talk. So where will the internet be in the future? Well, one place the internet will be is in your glasses. So you simply put on your glasses, and your glasses recognize people's faces. How many times have you met somebody and you say to yourself, I know this person. It's Jim, John, Jake. Who is this person? In the future, your glasses will say, it's Jim, stupid. Remember, you want to see his entire biography in your glasses. So when you see somebody, your glasses will recognize that person and print out their biography. And if they're speaking Chinese, translate from Chinese into English. We are very close now to what Star Trek people call universal translators. Google is putting millions of dollars into it, the ability to translate as you speak from one language to another. So let's say you're looking for a job. You go to a cocktail party. You know that some of those people in the cocktail party are heavy hitters. They're going to hire people, but you don't know who they are. In the future, you will know exactly who to suck up to at any cocktail party. You'll know exactly who the important people are. And maybe you don't want to look like a refugee from Star Trek. In the future, children will love this technology because children are driving this technology. You know that video games are bigger than Hollywood? I didn't know that until I looked at the numbers. Video games, just video games of little teenage kids, larger than the revenue of all of Hollywood. Kids will love this technology. Eventually, fashion models will adopt it. It'll be, you know, part of high fashion. What? You don't have the latest in internet glasses? I mean, what's wrong with you? That's so yesterday, right? Your glasses will have GPS. This is teleconferencing. Also, this is your home entertainment center. Wherever you are, you can lie back and you download any movie you want. Or this is your home office. You can work from your office here in your glasses. However, there's one downside. Let's say you don't wear glasses. If you don't wear glasses, what are you going to do? Put on contact lenses. These are internet contact lenses. You blink and you go online. Okay? Now, who will use this first? MIT students taking final examinations. Every kid taking a final examination will say, Mom, Dad, please, I gotta get those contact lenses. I don't want to have to study so much, but think about it. Why do we have to memorize all these things that we simply look up on the internet anyway, right? Well, in the future, science will emphasize concepts and principles rather than memorizing all the amino acids, memorizing the periodic chart. It's principles, it's concepts that drive science, not memorizing everything. So in the future, when you put on your internet contact lens, and let's say you are an artist. Artists will be the second group of people to buy this. Because artists, when they put on their contact lens, will move their hands, create beautiful works of art, and then, you know, move things around, rearrange things. And in their contact lens, they will see what will eventually become their work of art. Architects will love this. You build a building, but you want to change the design, change the rooms, no problem. Star Trek fans will love this, because what is this? This is the holodeck. Matrix fans will love this. This is one step to the Matrix. Also, tourists will love this, because let's say you're in Rome and you want to see the great Roman Empire ruins. It's really quite disappointing. I was really disappointed when I saw Rome the first time. There's nothing left, okay? Where's all the marble of the Colosseum? I was shocked when they told me that. All the marble was stolen by the Catholics to build the Vatican. So if you want to see the Roman Empire, go to see the Vatican. That's where all the marble came from, okay? What a disappointment. Anyway, in the future, tourists will see the entire Roman Empire recreated as you walk through the streets of Rome. The Chinese have already taken the first step. If you go to the Summer Palace, they don't have it in your glasses, but they have it on a PC. That as you walk around the Summer Palace, you see the Summer Palace as it was before the Western barbarians burned it down, right? So you can see how tourism is going to be affected. The military wants this because GIs can simply put on their contact lens and see exactly what's happening on the battlefield, eliminating the fog of war. So hey, this is going to be called augmented reality. Children love virtual reality, you know, computer games, stuff like that. That's for kids. This is called augmented reality. If you are a prospector looking for gold, you'll access satellites going overhead, and you'll see exactly where the oil deposits are and where things are. If you are an archaeologist and you're looking for ruins, you'll access satellites. You'll see exactly where the ruins are located via satellites. Now, you've seen this before. Where have you seen augmented reality before? Well, here's the governor of California in a very bad mood. The budget in California couldn't be passed. So here is Arnold in his true form. But you see, when Mr. Schwarzenegger looks at John Connor, his eyeballs recognize John Connor and spit out his biography. That's where you've seen this before in science fiction movies. The robots, when they see things, the glasses identify what they are looking at. But why should robots have all the fun? Why can't we have the fun? Why can't tourists have the fun? Students. I mean, imagine what you can do living in a holodeck, living in the Matrix. So augmented reality. You see people's biography, subtitles as they speak. You can actually see through objects. The military wants this, because if you're in a dogfight, you're sitting on, you know, $10 million worth of hardware. You don't want to lose that. If an enemy plane goes underneath your airplane, you are dead meat. You cannot see the enemy airplane underneath your feet, but you will in the future. You put TV cameras underneath the airplane. So as the enemy goes underneath your feet, the image is shot right into your contact lens. So you actually see right through your own feet. This is X-ray vision. The military has enormous interest in this. Architects, tourist attractions, all of that complements of physics. Now, let's say your living room now. Let's bring it down to your living room. What are you going to have in your living room? Well, with computer chips cost a penny. If you don't put a chip in something, your competitor will and drive you out of business. Chips will be everywhere because they're just so cheap. You put a chip in your wristwatch, and there's an internet wristwatch. You put a chip in, well, you put a chip in a telephone, it becomes a cell phone, except your cell phone will have multiple screens. And this is what a cell phone may look like in the future. You know, with a cell phone, you have the tiny little keyboard. Ever try to type in that tiny little keyboard? You feel like smashing that cell phone, right? I feel like smashing it. However, in the future, you'll roll out intelligent paper. Intelligent paper where every dot is a transistor. Every dot is a transistor. This is called OLED technology, OLED technology, organic light-emitting diodes. And you just scroll out your PC screen. This is called intelligent paper. This is intelligent wallpaper on the right. Wouldn't it be great to put up wallpaper, and then when you want to change it, you just say to yourself, I don't like that color. I don't like that design. Why don't you change color? And boom, your wallpaper changes color. Design, boom, just like that. Isn't that great? Well, it's coming. Intelligent wallpaper. Wallpaper that can be a PC screen, wallpaper that can change color, and on your upper left is your wallet. Today, your wallet pictures just sit there and do nothing. I mean, what a waste. In the future, your wallet pictures will move. In fact, because chips cost a penny, for God's sake, the chip costs less than the picture. So why not let your pictures move? So intelligent paper, that's coming. And this is your living room. Your living room is called the cave. It's 360 degrees, surrounds you in all directions. And you simply talk to the wall, and you can conjure up pretty much anything you want. Let's say you're a college student, and it's Friday night. All your friends are having a great time with a date, and you have no date. What do? We all know what you do. You get stone drunk. Well, in the future, you simply go to the wall and say, mirror, mirror on the wall, who's available tonight? Your wall screen scans all the other wall screen of all the other people who are also sitting in front of their wall screen saying, mirror, mirror on the wall, who's available tonight? And your wall screen already knows the kind of people you like, the hobbies and things like that, and sets up a date. Afterwards, you come back and you say, you know, I want to see an old-fashioned movie with my date. None of this high-tech stuff. I want to see Casablanca. Except remove Humphrey Bogart's face and put my face instead. Remove Ingrid Bergman's face and put my date's face instead. Now, some people say, well, you know, the future is going to be cold. It's going to be mechanical. But realize that when the internet was first created, it was cold and mechanical. It was male. It was about dominating over the Soviet Union. The Pentagon is not going to fund a project like the internet just so that you can be on Facebook and gossip with your girlfriends and boyfriends. That's not why the internet was created. It was to dominate over the Soviet Union. That's why it was created. So it was male. Now the internet is female. 51% of the users of the internet are women, and it's about touching people. So the internet went from dominating over another country to touching other people around the world. Your kids today probably play video games with people in South Africa, Russia. They probably know more about people in Iceland than their next door neighbor, okay? So that's about touching people. I still remember reading a story once about the telephone. When the telephone first came, there were all these people denouncing the telephone. They said, uh-oh, that's the end of dinner table conversation. We'll all be talking to this mysterious, disembodied voice in the ether, okay? We'll lose the art of conversation. They all denounced the telephone. And you know something? The critics were right. We do talk to this disembodied voice in the ether. We do not talk necessarily to our family members at dinner. And you know something? We love it. Because our circle of friends expanded from 5 people to 50 people. That was huge, from 5 people to 50 people. Now with the internet, you go from 50 people to 5 million people. And look what it's done to the Middle East. So I tell you, this is big. Now, this is also creating a problem for the English language. When we put chips everywhere, chips are now getting into toys. Toys are becoming intelligent at Christmas. This is causing a problem for the English language. We have a contradiction in terms called smart Barbie dolls. Another contradiction in terms is Microsoft works. That is also a contradiction in terms. As I said before, if chips are a penny, then why not put them everywhere, including, well, glass. Why should glass simply sit there and do nothing? I mean, what a waste, right? This is intelligent glass. It's an intelligent PC. Let's say you're tired of looking out the window and seeing the same darn thing every single day, and you wish you had a room with a view. Well, you just go to the glass and say, I don't like this view. Change it. I want to see the Eiffel Tower. I want to see the Taj Mahal, and bingo. This is the future of windows. And television. Remember those clunky glasses you have to put on when you see 3D? left and right, polarized, and so on and so forth. In the future, you can forget those glasses. The polarization is in the screen itself. The screen consists of millions of vertical lines. Vertical lines. Each one is a prism, a vertical line that's actually a prism. That prism splits an image in half. One goes to your left eye, one goes to your right eye, and it gives you 3D perception without glasses. This is how you will see movies in the near future. This already exists. I had a demonstration when Nintendo came out with their version. You have to be in the sweet spot. You can't be everywhere, but if you're in the sweet spot, whoa, everything jumps out at you. This is the future of your office. Computers today are very expensive, and you have to move everything around your computer. But, you know, if computer chips will cost a penny, this means that you'll have scrap computers. You'll scribble on something, and you simply throw it away. As you go from room to room, the scribble follows you in the cloud. Because how do we meter electricity today? How do we meter water? We meter water, we meter electricity by you get a bill. Well, that's how computer power is going to be distributed. The laptop will disappear, and we'll simply compute from the cloud. We'll use it as a utility. We'll meter computer power just like we meter water and we meter electricity. So this is your office of the future, and this is your cubicle of the future. It'll be so attractive, you'll spend all your time doodling and not doing any work. Productivity could fall if it gets too attractive. This is your car of the future. Look at the guy on the left. Notice that he does not have his hands on the steering wheel. No, he is not suicidal. He drives a driverless car. Google is spending millions of dollars to make this a viable technology in 8 years. In 8 years' time, this will hit the market. It is driven by GPS. BBC television put me in this car, this very same car, and I was driving the car like this, and then the cameraman said, okay, let go. I said, what? Let go. So I let go, and there I was driving my car. Try it tonight. Drive your car going like that, okay? Well, it uses GPS. It is actually safer than a human. Humans fall asleep. Humans get drowsy. Humans get drunk. Humans do all sorts of nonsense. These things don't. They're actually safer than humans. Radar is in the fender to warn you against any impending collision. Millions of chips will be in the road because chips only cost a penny, after all, cheaper than paper. And so traffic jams will be eliminated because on your TV screen, you will know exactly where all the traffic jams are because there are chips in the road. And now let's go a little further into the future. What we saw was like 15 years in the future. Now let's go farther than that. Now we're talking about mind control. Now we're talking about robots as we get into mid-century. Well, first of all, that's that movie on the left, Surrogates, where you have an aging body that gets older and older every year, but you mentally control a robot. That robot is perfect. It has the body of Venus or Adonis, and after a while, humans prefer to look like Venus and Adonis and decide to abandon their mortal molding bodies. And on the right, we have Avatar, where you control a clone on another planet. This is science fiction, right? Yeah, but it has a basis in reality. So hold on to your seats. Telepathy. This is the power of the gods. Telekinesis, to be able to move objects with the mind. That's what gods do. That's not us, yet. However, this is a toy. You put a helmet on like this. It exists today. It's marketed today. It picks up your radio signals from the brain. It's an EEG scan. And computers now are so good, they can actually recognize the patterns of thought. So when you think, you can actually move that object on the right. I once saw an episode of Star Trek where the crew of Star Trek lands on a planet, and Apollo lives on that planet, a god who could do all sorts of fantastic feats, and the crew of the Enterprise think, uh-oh, we're outclassed. I mean, we're up against a god, right? But then they realize that he's not a god at all. He's immortal, but he controls a power supply. The power supply then energizes computers which do all the magic. He is a human. And so the crew of the Enterprise destroys the power source, and Apollo is reduced to a man. Well, that's how we're going to do it. Humans will have thought patterns recognized by computers. Computers then do all the work. Here's how it works. On the lower right is a person who has a stroke. He is paralyzed. He cannot move at all. But at Brown University, they put a chip in his brain, connected the chip to a laptop, and the person now can answer email, write email, surf the web, play video games, do crossword puzzles, and he is a vegetable. It's very sad. The guy in the lower left had a massive stroke. His parents, his loved ones cannot communicate with him. He's a vegetable. He sits there, does nothing all day. Well, they put a chip in his brain, shown here, connected it to a laptop, and connected the laptop to a computer. Now, anything you can do on a computer, he can do too. He can talk to you. He can touch. He can reach out and exchange ideas. This is a real breakthrough. Now, realize that one of my colleagues, Stephen Hawking, is very soon will lose control over his facial muscles. Right now, Stephen communicates with the scientific world by blinking and making facial grimaces. He will lose that capability pretty soon. So I was at a cocktail party last year in Stephen's honor, and in the cocktail party was the man who built this device. So some people are thinking that maybe we'll put Stephen Hawking on this device so he'll be able to communicate mentally with the rest of the world. So Honda Corporation sees money here. Here is a man. He puts on EEG sensors all over his head. Computers recognize what these patterns mean and drives a computer. It's a robot. This robot is controlled by a human. This is the movie Avatar come to life. It's the movie Surrogates come to life. Humans who can control robots. So next time someone says to take out the trash, well, you just put on your helmet. And your robo clone takes out the garbage. Of course, the robot could have the power of a Superman, too. Mind reading is possible. We're now getting a dictionary of thought. Now, on the left is when people tell the truth. When you tell the truth, nothing much happens to the brain. It's effortless telling the truth. But when you tell a lie, first you have to know the truth. Then you have to invent the lie. Then you have to make sure the lie is consistent with the cover-up. And then you have to make sure that the cover-up is consistent with all the other lies you've been telling all these years. That's a lot of brain power. So on the right, your brain lights up like a Christmas tree when you tell a lie. Now, of course, this has to be tested in the courts. Some people think it's not that accurate, but it just goes to show you that we are beginning to have a dictionary of thought. And in Tokyo, by the way, they even have plans to photograph a dream. This was once considered totally outrageous. You saw the movie with Leonardo DiCaprio, Inception? Well, they actually have a program to photograph a dream. Here's how it works. When you dream, your visual center is stimulated just as if you're looking at something real. You can actually see that part of the brain illuminate. Now you see a pixel of light, a dot of light. That corresponds to a certain pattern. You move the pixel to the next spot, and that corresponds to a certain pattern. Then you move the pixel everywhere, like in a TV screen, and you have a dictionary. Every dot corresponds to a pattern. This dot corresponds to that pattern. Then when you see a pattern, you can then reconstruct the dots. They were successful. For simple dots, they can actually tell what you are thinking of and what you're looking at without exchange of any words. A person was given a U formation, a series of lights in a U, and the computer said, U. So this is Avatar come to light. Now, there's also a morality tale. When you have the ability to mentally control the world around you, that is the power of what we call a god. But there's also a problem. If you saw the movie Forbidden Planet, it's one of my favorite science fiction movies. When I saw it when I was a kid, I was floored. On the upper left is this tremendous empire created by the Krell. They were 1 million years ahead of us. Tremendous technology. Here is just their power supply. You can see the enormous power that the Krell Empire assembled. Their masterpiece was to create everything by thought. You would think things and it would come true. On the lower left, you simply imagine anything you want and it comes to be. So you imagine a woman and there's the daughter of the scientist materializing. Robots are effortlessly created by the Krell. So this was the power of power without instrumentality. That is mind control, mental telepathy, telekinesis, the ultimate power of the mind. But then they died. This great Krell empire died one day. And the question is why? At the very end of the movie, they reveal why this Krell empire, at the peak of their power, died. And the answer was, the very night they turned on the machine to give them this godlike power, they fell asleep. And when you fall asleep, you have nightmares. This machine turned nightmares into reality. Everything they could dream of, all the monsters, all the savagery of their past came out, and they all committed suicide overnight. So there's a lesson here. With infinite power comes infinite responsibility. Now let's say a few things about medicine. And then I'll end early. The book, by the way, has hundreds of predictions. I can't possibly go through all the predictions in the book. But let's just say a few things about medicine. When this movie came out, Raquel Welch was floating in somebody's bloodstream. Everyone said, give me a break. Raquel Welch floating in somebody's bloodstream in a submarine? Well, we're getting there. Computers are getting smaller and smaller and smaller. Here's an aspirin pill, hollowed out. It has a TV camera inside. This is real. A TV camera and a chip. It photographs your inside as you swallow it. It's guided by a magnet, so you know exactly where it is at any given point. It takes motion pictures of your stomach and your lower intestines and your large intestines. We all know what middle-aged men hate the most. The C word, colonoscopy. Well, this invention gives new meaning for the expression Intel inside. And we now have nanoparticles, molecules. This is real now, not science fiction. Molecules that kill cancer. Now, when you have chemotherapy today, it's awful. Chemotherapy is horrible. Your hair falls out. You vomit all the time. You're tired. Your skin is all aged. That's chemotherapy. This will replace chemotherapy. In one test, it was 90% effective against cancer cells. We're talking smart bombs. Smart bombs against cancer. How does it work? Cancer has large, raggedy holes in it. Cancer is mutated. It's irregular. It has large holes. A normal cell has small, tiny, round holes. Very regular, small, tiny holes. That's a normal cell. We can now machine molecules halfway between the two. They are too big to fit into an ordinary cell, but they float right into a cancer cell. I tell you, man, this is big. This is real big. It means we now have a new way to attack cancer. You know that Aretha Franklin is dying because of pancreatic cancer? You know that Patrick Swayze of Dirty Dancing died because of pancreatic cancer? You know that Steve Jobs of Apple has pancreatic cancer? We used to think that it was very aggressive. 2 years, you're dead. We used to think it was very aggressive. Then we sequenced the genes inside pancreatic cancer. We were wrong. Pancreatic cancer is a slow-growing cancer. It takes 20 years to create a tumor. 20 years. Only in the last 2 years do you feel it. That's why it kills so rapidly. It was growing in your body for 20 years. Only in the last 2 years do you feel it. Now we'll be able to zap it and also detect it. How will we detect cancer in the future? Ladies and gentlemen, you are now looking at the cure for cancer. Today, when you go to the bathroom, nothing much happens 3 times a day. In the future, your toilet will say, well, you drink too much, eat too much sugar, too much salt in your diet. Isn't the future wonderful? Even your toilet will tell you that you eat too much. But this is a smart toilet. It picks up proteins emitted from cancer colonies, 100 cancer cells. Today, for example, if you feel a tumor in your breast, it's too late. It's really too late. They don't tell you this. But you have 10 billion cancer cells growing in your breast. Surgery is required immediately. No ifs, ands, or buts once the diagnosis comes. But that cancer was going for 10 to 20 years. In the future, your toilet will tell you that you now have 100 cancer cells emitting proteins that are picked up by DNA chips, and you should get surgery sometime between now and 10 years from now. You will have 10 years warning. This means the word tumor may disappear from the English language. Here's how we do it. This is incredible. In fact, Mass General Hospital in Boston is thinking about mass producing these things in 3 years. This could hit the market as early as 3 years. This device uses transistor technology, except instead of it zeroing in on transistors and electrons, it zeroes in on cancer cells. It zeroes in on tumors. It zeroes in on proteins, enzymes emitted from cancers. This thing is an early warning system, not against tumors, against cancer colonies. The device that Mass General Hospital wants to market, it can detect one cancer cell in a billion. One cancer cell in your blood in a billion. I tell you, man, this is big. This is real big. It means that one day we may be able to get a grip on cancer. And of course, if you watch Star Trek, everyone used to laugh when Spock would take out his tricorder. The tricorder can see inside your body. It diagnoses disease from a distance. And people would say, ha, that's impossible. I mean, you know, the only reason why they invented this thing is because they're too cheap to have any real technology on the Star Trek set, right? For example, why do everyone get beamed from place to place on Star Trek? Because of budget cuts. Roddenberry wanted them to land on rocket ships, the normal way. But oh no, Paramount Studios says, we're running out of money. Let's just beam them. And that's where beaming came to be. It was budget cuts. Well, on the left, is an MRI machine today. Look at the size of that thing. When I was in high school, I had a summer job at Berry & Associates. My boss there won the Nobel Prize for this machine. Paul Ernst won the Nobel Prize for creating the MRI machine. On the right is the world's smallest MRI machine. Look at that thing. It's 1 foot tall. Something that is the size of a room, now 1 foot tall, made in Germany. And the Germans now predict that this thing will ultimately go down to the size of a cell phone. When this thing goes down to the size of a cell phone, in your living room, you can see right inside your body. You just move the thing up and down over your body, and you can see all your internal organs. So let me say a few things about DNA, and then we'll close, and I'll take questions, and then we'll sign books. DNA is perhaps the most important discovery of the last several decades. A physicist, Francis Crick, pushed this thing through with, of course, James Watson. This is an ear. It's made out of plastic. You take cells from your ear, seed it, hit it with growth factors, your ear cells grow into this mold of plastic, and then the plastic dissolves, is biodegradable, leaving a perfect ear. This is bone on the left. Bone on the left, ears on the right. You realize that today we can grow cartilage, noses, ears, blood vessels, heart valves. The first bladder was grown 3 years ago. The first windpipe was grown last year. You realize that we're talking about a human body shop, the ability to grow organs and specifications. This is coming faster than you think. The next organ to be grown from your own cells is the liver. 5 years, I think, we'll have the first commercially available liver. So for all you alcoholics in the audience, take heart. Mickey Mantle died because he couldn't get a liver. That's how our great American Yankee died. He couldn't get a liver. We'll grow livers in the future. So let me try to wind up now. Let me just say a few more things and we'll wind up. One is that, well, there's a dark side to this. This is the smart mouse. On the left is an ordinary mouse. On the right is the smart aleck mouse. The smart mouse has better memory, goes through a maze much faster. And this is the mighty mouse. It is muscle bound. We have now found a counterpart in a young boy in Germany so we can't call it the Mighty Mouse gene anymore. We now call it the Schwarzenegger gene. This, of course, leads us to the ethical implications of all this. We're going to be able to control our bodies genetically in the future. The Olympics are the first casualty. The Olympics have already set up a committee to investigate cheating when muscle-bound athletes bulk up genetically. It's very hard to determine who these people are because steroids are just chemicals that can be picked up with a urine test. Now we're talking genes. We're talking proteins, much more difficult to detect. But there's also a nice side to this, and that is we are now teasing apart the aging process. You realize that we've already discovered about 60 genes that regulate the aging process. This is huge. Aging, I mean, who wants to get old, right? It turns out that animals live different ages. Look at the chimpanzee. The chimpanzee lives half as long as us. We are 98.5% identical to the chimpanzee. Therefore, only a handful of genes separate us from the chimpanzee. Now think about that. If we live twice as long as the chimpanzee, and only a handful of genes separate us from the chimpanzee, we will find the genes that control the aging process. Already, we can double the lifespan of most animals with yeast cells, fruit flies, spiders, insects, mice, rabbits, dogs, cats, and now primates. We can literally double their lifespan. So maybe, using our understanding of genes, we may be able to live much longer than before. Maybe not my generation, but maybe our kids or grandkids may decide that when they hit the age of 30, they may like 30. They just may want to stay at 30 for several decades. This is something that is well within the realm of possibility. Not yet, but it's coming pretty soon. Now, let me end on one last note, and then we'll take questions, and then I'll sign books. When I was at the Einstein Centennial, many people gave tributes to the great Einstein, whose work makes many of these things possible. Lasers, high tech, comes from the photon theory of Albert Einstein. But my favorite Einstein story is this. When Einstein was an old man, he was tired of giving the same talk over and over again. So one day his chauffeur comes up to him and he says, "Professor, I'm really a part-time actor. I've heard your speech so many times, like a script. I've memorized it. So why don't we switch places? I will put on a mustache and a beard and look like Einstein, and you can take a rest and be my chauffeur." Well, the trick worked. They switched places. The actor gave brilliant talks because he was an actor after all. But then one guy in the back, a mathematician, asked a very difficult question. And Einstein thought, oh, the game is up. But then the chauffeur said, "That question is so elementary that even my chauffeur here can answer it." Okay, thank you very much. You've been a great audience.
So we'll now be taking questions. If you raise your hand, the microphone will come to you, and please stand up when you ask your question and wait for the microphone.
Okay, so
First question right over here.
Okay.
First, I would say congratulations for an absolutely super talk. But I would like to ask a question. What do you think is the feasibility within the next couple of decades of changing the chimp or some other animal to such an extent that they could be used in experiments to bypass clinical trials of human beings, and we could do this for metabolic diseases, malignant disease, or what? But anyway, have humanized experimental animal and have them in sufficient quantity to do a trial with good statistics.
Well, that's still difficult because side effects vary from animal to animal. We would have to get an animal that's pretty close to a human. Let me give you an example. We've made enormous breakthroughs with mice. We can do things genetically with mice that seem like miracles. The problem is many of them don't transfer to humans. That's the problem. So if you read the Science Times, you read Science Daily, all these breakthroughs being made with mice. But then at the very bottom of the article it says, oh, by the way, many of these therapies don't carry over to humans. And so that's why what your suggestion is very tantalizing, that maybe we should try animals that are closer to humans. That way we won't have the problem of side effects, the problem that, you know, the mouse immune system is quite different from the human immune system. But it also has to be done carefully, because once you go to monkeys, monkeys can feel. They're, you know, they're more human-like in their emotions and the way they express themselves. So we have to make sure that they're not treated badly. We have to make sure that they're not experimented with needlessly or subjected to unnecessary experimentation. But yeah, that could change things, but it has to be done very carefully, because we want to make sure that the animal that we're looking at, it has an immune system very close to ours, so that results will transpose from one to the other. But we also want to make sure that we don't hurt the animal in the process. Okay, next question.
We have another question up here.
Hi. Thanks for coming. With all this new technology, is it going to require a lot more power and cooling for all this, the electronics and computers? Or is the future basically all the new technology is reduced power consumption and moving downward, I guess, in terms of our use of power?
Well, as far as power is concerned, we'll be using less power but more efficiently. Those contact lenses, for example, one of the engineering problems is heat generation. We can miniaturize computers down to the size of the head of a pin. That's not the problem. Miniaturization is not so much the problem with the internet contact lens. More important is heat generation and also focusing. So those are the technical problems that still have to be worked out. So as the technology gets more advanced, it means that smaller and smaller chips use less and less power. However, on the other side of the scale, once we start to go to super chips, okay, I mean chips that really like push the very boundaries of artificial intelligence, there is a problem with heat. It turns out that very soon, Moore's law will break down. I'd say in about 10 years' time, Silicon Valley could gradually become a rust belt. And there are two reasons for that I mentioned in physics of the future. One is heat generation. If you put more and more power into a chip, you generate more heat. Ultimately, you can fry an egg. You'll be able to fry an egg on a chip. That's how hot these chips get, and eventually they melt. The second problem is even deeper, and that is the Heisenberg uncertainty principle. Right now, your chip, in your Pentium chip, has a layer 20 atoms across. That's the smallest layer in your laptop computer, 20 atoms across. By 2020, it'll be 5 atoms across. When you hit 5 atoms, you're bumping up against the uncertainty principle. You don't know where the electron is anymore, and it leaks. It short circuits. So there are two problems with regards to superchips: heat generation and leakage. That's why some of us want to go to quantum computing, computing on atoms, which are very efficient. The problem there is interference. The world's record for a quantum computing calculation is 3 times 5 is 15. That's the world's record for a quantum computing calculation. Now, you may not be so impressed, but go home tonight, multiply 3 times 5 is 15 using 5 atoms. So here's your homework assignment. Take 5 atoms, multiply 3 times 5 is 15. Then you begin to realize, oh my God, this is real hard, okay? So yeah, power consumption becomes a problem at the other end when we want to have super chips. I mean, we want to push the boundary of computer power, okay? Next.
It's over here.
Dr. Kaku, good evening. So what has the scientific community not figured out yet and should have by now?
Well, let's talk about jetpacks and flying cars, okay? Everyone wants to know, hey, where's my jetpack? We've been watching Buck Rogers for 2 generations now, right? Well, it's technical. You know, the Nazis had jetpacks during World War II. The Nazis put hydrogen peroxide on a soldier and shot them over rivers. Sometimes the bridge was washed out or destroyed, and you wanted to send somebody across a river. The fastest way was a jetpack. The Nazis developed it. The problem is the jetpack only lasts for just a few minutes, like 2 or 3 minutes. Maybe you saw James Bond, right? James Bond was hovering for many, many minutes. Well, the people who did that scene with James Bond spliced together many scenes. They had to shoot him up, he came back down. Shoot him up, came back down. They spliced it. So the problem with jetpacks is not jetpacks. The problem is longevity of the fuel. That's where nanotechnology comes in. In the future, we'll have nano batteries that can power jetpacks for longer periods of time. But right now, hydrogen peroxide is still the chemical of choice. It only lasts for a few minutes. Flying cars. For the Discovery Channel, we actually filmed a flying car. It takes off just like you see in the science fiction movies, 2 gigantic rotors, but the gas mileage, oh my God, the bill. I mean, you gotta be a millionaire to buy one of these things, right? Commuting to work, yeah, sure, if you're Bill Gates. The gas mileage is horrendous on these flying cars. So what we want is magnetism. How much energy does it take to shoot a nice puck across a skating rink? 0. There's no friction. You realize that most of the energy going into a car goes into overcoming friction. Think about it. There's no friction. You simply blow on the car, and the car moves. You just blow, okay? So the point here is that in the future, we will have supermagnets, superconducting magnets. We don't have them yet. They have to be at room temperature. But when we have them, we'll enter the age of supermagnets. We'll go from the age of electricity to the age of magnetism. And for you kids out there, this means hoverboards, okay? Real hoverboards in the future. Okay, another question?
Yes, thank you so much for your directing some of your science towards cancer. And I'm just curious as to whether they're working on other end-stage cancers, such as colon cancer.
I just had dinner with one of the leading scientists at the National Institutes of Health in Bethesda, Maryland. She's working on nanoparticles. These nanoparticles are targeted. They target cancer cells. In fact, the patients she's working with are end-stage cancer people, doctors have given up hope. They've given up hope, so they allow this very super high-tech therapy to be used on them. And so far, she says, yeah, in some cases, we've seen miracles, absolute miracles take place. Of course, it takes years to get FDA approval. There could be side effects. You have to be careful with this technology. But she told me that in her opinion, and again, this is just her opinion, this is going to be big, huge. It'll take time, but it means that we're going to attack cancer with smart bombs. Now, this is not a cure for all cancer because every cell has a different kind of cancer. We have a human genome project for cancers individually. You realize that we now know that when you get a cancer, you have something on the order of 20 to 30,000 mutations in your cell. In other words, every time you puff a cigarette, you get about 5 to 10 mutations. We can even calculate how many mutations you get per cigarette. That's how good it is now. And it is horrendous. Every time you puff, you say to yourself, ha, see, I didn't die. Yeah. Well, yeah, you just messed yourself up with 5 mutations, right? And so by the time you die, you got like 20, 30,000 mutations, and then it's all over. It's incurable. So what we're doing now is we're attacking these cells at the molecular level. Several ways of doing it. One is with gold nanoparticles. Gold goes right into the cell, and then with laser beams excite the gold and rupture the cell wall of the cancer. So these are smart bombs that go right in, disrupt the cells by laser beams. Okay. Second is P53. P53 is a gene involved in 50% of all common cancers. You can actually home in on a cancer cell, deliver P53 to it, and knock out the cancer cell that way. So there's several different avenues, and I tell you, this is going to change everything. But you got to be patient. It's going to take time to perfect it because it's just coming out in the last few years. Real breakthrough, 90% effectiveness in one trial. This is big, but again, don't expect it to hit the market tomorrow. It's going to take years to get FDA approval. But we will look at chemotherapy like we look today at bloodletting. You know how George Washington died? In textbooks, they never tell you this. George Washington was killed by his doctors. He was bled to death. That's how the father of our country died, because in those days, blood was considered bad humor. So if you got sick, they bled you to death. And that's how George Washington died. We'll look at chemotherapy the same way.
In your opinion, what nation is in the best position to leverage these new technologies, and what do you think will become of the second and third world countries who may be left out?
Okay, in the book, I interviewed economists. And what they say is that capitalism itself is making a transition from commodity capital to intellectual capital. Now, what does that mean? Tony Blair likes to say that England derives more revenue from rock music than it does the coal mining industry. Coal mining is a commodity industry. It is a thing. Prices get cheaper every year. This morning, you had food, breakfast, that the King of England could not have had 100 years ago. You have delicacies, things imported from around the world, things that 100 years ago were unavailable to the King of England for any price. What happened? Mass production, better containerization, better shipping, more competition. It's a commodity. Commodity prices have been going down steadily for 150 years, except oil. A few commodities don't obey this rule. The real thing that's going up is intellectual capital. Intellectual capital is rock music, it's artwork, it's the internet, it is science, it is writing a book, telling a joke, things that robots cannot do. Intellectual capital. Why is it so precious? Because you cannot mass produce the brain. It's as simple as that. You can mass produce food. You cannot mass produce the brain. To create a software engineer, to create a new Madonna, to create a rock and roll star, first you have to give birth to one the old-fashioned way. It takes 9 months. Then you got to send them to elementary school. You got to send them to college, and then they rebel against you. That takes time. Food, you just crank out, okay? Now, ask yourself a simple question. How many nations in the world understand this? How many nations are still wedded to food production? And then you begin to realize, oh my God, there's a huge chunk of the world economy that does nothing but create food. Those nations could see their economies get smaller and smaller and smaller. Now, the Chinese are not stupid. They know this. First, they use commodities, cheap labor, to leverage to the next level. They're sending all their best minds to the United States, where I see them. Half my physics department is Chinese, from China. We get the best scientific minds of China, the cuspia, the cream of the Chinese crop. They all come to the United States, okay? So the Chinese aren't stupid. Deng Xiaoping's son was a laser physicist at Rochester University, okay? The question is, are we smart enough to know this? That's a question mark. And so the nations that will prosper in the future will be those nations that understand this. You have to have commodities, but the future lies in intellectual capital. That means artwork. That means telling a joke, writing a movie script. That means science. That means anything that the mind produces that robots cannot. Things involving imagination, talent, creativity, analysis, human values. These are all things robots cannot do.
Question up here.
While you're here, I figured I'd ask, what are your thoughts on the future of string theory and applications in, I don't know, future applications of string theory? I'm not sure how to ask this question.
Well, the second question is very easy to answer. The practical applications of string theory in your lifetime are 0. Okay? Very simple. However, if we live long and we cruise at age 30 for many, many a lifetime, then we start to have some rather interesting consequences. String theory is the only theory that can answer the question, is time travel possible? Is it possible to drill a hole in space and time? Are wormholes possible? Are gateways, portals to other dimensions possible? Can we bend space-time into a pretzel? Only string theory has this capability. What happened before the Big Bang? Are there other universes? Are there other dimensions? And testing it, we will test it with the Large Hadron Collider. The Large Hadron Collider will test more than just the Higgs boson. We're looking for higher dimensions. The Large Hadron Collider, the most expensive machine on Earth, is looking for the presence of other dimensions. That's a prediction of string theory. And so this is big. This could change everything. We are now testing the so-called untestable theory, the outlines of string theory. And as far as for those critics of string theory, sometimes they say, give me an alternative. Maybe I don't like string theory. Give me an alternative. Well, there are none. This is the only game in town. It's the only theory that's been shown to be finite. All other theories, bar none, have either been shown to be infinite or they haven't been tested yet against infinity. All other theories are shown to be divergent. String theory is the only finite theory. Okay, maybe just one last question, because
Yep.
I know you want me to sign your books, right? So one last question, and I'll definitely sign your book. And then you can sell it on eBay, you know. They're worth something, you know that? Okay,
Yep,
one last
so
question.
we're taking our last one right here.
Nuclear power has been in the news a lot lately. Even if we shut down all the nuclear power plants in the world and didn't build any new ones, we still have the problem of the spent fuel pool. So is the physics community going to have a new alchemy solution to detoxify spent reactor fuel?
Well, first of all, as you know what's happening in Japan, many people are leaving. In fact, my relatives evacuated. The situation in Tokyo is still stable, but it's getting worse every day. As you know, tap water in Tokyo is now twice the limit for infants. The United States government has said they're not going to purchase any foods from certain provinces around the reactor. And the United States government is advocating that all Americans evacuate from all of Japan. It's not mandatory, but they are making that recommendation. So things are getting very bad. And then the question is, will nuclear power be part of our future? Well, when I was in high school, I went to the National Science Fair. I built an atom smasher, a 2.3 million electron volt atom smasher, blew out every fuse in my mom's house. But when I went to the National Science Fair, I met an atomic scientist who took me under his wing. And he was actually my mentor for many, many years. He got me a scholarship to Harvard, in fact. His name was Edward Teller, father of the hydrogen bomb. I knew him quite well, the family quite well. And he was famous for being pro-nuclear, but he was also famous for making the statement, nuclear energy is so dangerous, it does not belong on the surface of the earth. It belongs underground. Now just think, if they had built that reactor underground and a tsunami had hit it, all they would have to do is put a manhole cover on it and just walk away. But oh no, they had to build it above ground, okay? Where they had 15-foot walls guarding against the tsunami, but the tsunami was 25 feet tall, went right over the wall. And where did he put the generators? Normally you put the generators on high ground. At Fukushima, they put the generators in the basement. I can't think of anything sillier than putting all your generators in the basement where you have a 25-foot wave coming by. The generators were all knocked out instantly in the first opening seconds of the tragedy. Complete wipeout of all safety systems because the generators were in the basement. Now, you mentioned nuclear waste. Where do we put our nuclear waste? Well, if you've been following the news reports in Japan, they store nuclear waste on site. On site. That's why we're having problems with spent fuel explosions now. Unit 4 just blew up last week, containing spent fuel rods. In the United States, we have the same problem. We have no Yucca Mountains, because Obama canceled it. We have no Yucca Mountains for the storage of nuclear waste. So where do we put nuclear waste? We leave it on site. We're witnessing a case of nuclear constipation. All this waste is backing up at all the nuclear power plants in the United States. So it's a Faustian bargain. Faust was a mythical figure who sold his soul to the devil for unlimited power. We have a Faustian bargain. We have to democratically decide whether we also want to be wedded to this. But in my book, I mentioned that there is another kind of nuclear power, which is sometimes a laughingstock, but actually will probably come to be by mid-century, and that is fusion power. Fusion power is the bet that the French are placing on the future. The French and the European Union, with the United States, they're building the ITER fusion reactor to become operational by 2020. By 2020, we could have an operational fusion plant that uses seawater as its fuel. So instead of using seawater to cool your melting core, which releases nuclear waste over Tokyo, we'll have no nuclear waste at all. And we'll use seawater as the fuel rather than the coolant. But again, that's for mid-century, that's not for now. But by mid-century, we could be entering the fusion era where the energy source that everyone fights for is seawater. Okay, so that's the last question. So what I'm going to do now is sign your books. Okay.